3981. How does the wing design feature, washout, affect the production of lift? A. The wing tips continue producing lift when the main body of the wing is not producing lift. B. The main body of the wing continues to produce lift when the wing tips are not producing lift. C. The center of lift moves from the trailing edge of the wing to the leading edge of the wing as the wing begins to stall. The correct answer is A. The wing design feature, washout, refers to a decrease in the angle of incidence from the root to the tip of the wing. This means that the wing tips have a lower angle of attack compared to the main body of the wing. This design helps in producing a more gradual stall characteristics and enhances the safety and controllability of the aircraft. During a stall, the wing tips, having a lower angle of attack, continue to produce lift while the main body of the wing may be stalled. This allows for better aileron control and helps to prevent tip stall, improving the overall lift production and stability of the aircraft. 3982. The wing of a weight-shift aircraft twists so that the angle of attack, A. From the center of the wing to the wing tip is variable and can be adjusted by the pilot in flight to optimize performance. B. Changes from a low angle of attack at the center of the wing to a high angle of attack at the tips. C. Changes from a high angle of attack at the center of the wing to a low angle of attack at the tips. The correct answer is C. In a weight-shift aircraft, the wing is designed to twist along its span. This means that the angle of attack of the wing changes from a higher angle of attack at the center of the wing to a lower angle of attack at the wing tips. This design is known as wash-in/washout or wash-in/washout twist. The purpose of this wing twist is to achieve a more desirable lift distribution along the wingspan. The higher angle of attack at the wing root helps to provide sufficient lift for the center of the wing, while the lower angle of attack at the wing tips reduces the likelihood of tip stall and improves the roll characteristics of the aircraft. 3983. During flight, advancing thrust will A. Increase airspeed. B. Cause the aircraft to climb. C. Cause the aircraft to increase airspeed and climb. The correct answer is B. Advancing the thrust or increasing the power output of the engine in an aircraft indeed leads to a climb. When the engine produces greater thrust, it generates a higher amount of force that propels the aircraft forward. This increased forward force counteracts the force of gravity and creates an upward vertical acceleration. As the aircraft accelerates, the wings generate more lift due to the increased airflow over the airfoil surfaces. The combination of the upward thrust and the increased lift exceeds the force of gravity, causing the aircraft to climb in altitude. During the climb, the pilot can control the aircraft's pitch angle and rate of climb by adjusting the elevator control surfaces. By increasing the pitch angle, the pilot can further enhance the climb rate and altitude gain. Conversely, reducing the thrust or adjusting the pitch angle downward will result in a descent or level flight. It is important for pilots to understand the relationship between thrust, lift, and the resulting climb. Proper management of engine power and control inputs allows for safe and efficient climbs, contributing to the overall performance and maneuverability of the aircraft. 3984. The torque effect of an engine that rotates clockwise in a powered parachute is counteracted by A. Increasing the length of the right and decreasing the length of the left riser cables. B. Decreasing the length of the left riser cables. C. Decreasing the length of right riser cables. The correct answer is C. The torque effect, resulting from the clockwise rotation of the engine in a powered parachute, can induce an unwanted yaw or rotation to the left. To counteract this effect and maintain balanced flight, adjustments are made to the length of the right riser cables. By decreasing the length of the right riser cables, the lift distribution between the wings can be modified. This adjustment creates a compensating force that opposes the torque effect, effectively reducing or eliminating the yaw tendency. The modification of the right riser cables allows for precise control over the lift distribution and helps counterbalance the rotational forces generated by the engine. This adjustment is typically made during the initial setup and configuration of the powered parachute or when flight characteristics need to be fine-tuned. It is important to note that the adjustment of the right riser cables should be done carefully and in accordance with the manufacturer's instructions and guidelines. Proper training and understanding of the aircraft's flight characteristics are crucial for pilots to make accurate adjustments and maintain stable and controlled flight. By addressing the torque effect through the adjustment of the right riser cables, pilots can enhance the stability and maneuverability of the powered parachute, ensuring a safer and more enjoyable flight experience. 3985. The steering bars A. Are used during taxi operations with the parachute stowed. B. Control the outboard trailing edge of the parachute. C. Control the main landing gear brakes. The correct answer is B. The steering bars, or control bars, are essential components for maneuvering a powered parachute. They provide direct control over the outboard trailing edge of the parachute wing, allowing the pilot to navigate the aircraft effectively. The steering bars are typically located within the pilot's reach and are connected to the wing through control lines or risers. By grasping and manipulating the bars, the pilot can exert control over the wing's trailing edge, which directly affects the flight characteristics of the aircraft. To initiate a turn, the pilot can pull one steering bar while pushing the other. This action causes the trailing edge of the wing to change its shape and generate differential lift, resulting in a roll and a change in direction. By varying the amount of input on the steering bars, the pilot can control the bank angle and the rate of turn. The steering bars offer intuitive control, allowing the pilot to make precise adjustments and maintain stability during flight. By mastering the use of the steering bars, pilots can navigate the powered parachute with accuracy and confidence. It is important for pilots to receive proper training on the use of the steering bars and to familiarize themselves with the aircraft's specific control characteristics. Regular maintenance and inspection of the control lines and risers are also necessary to ensure their integrity and reliable operation. In summary, the steering bars play a vital role in controlling the outboard trailing edge of a powered parachute wing. They provide the means for pilots to manipulate the wing's shape and control the direction and bank angle of the aircraft, enabling safe and efficient maneuvering in flight.